Assalamualaikum warahmatullahi wabarakatuh to all my beloved student.
Waalaikumsalam warahmatullahi wabarakatuh.
How are you today?
Good, sir, good.
Okay, today I will show you all how to do the simulation using ANSYS 2022. Okay, first step, we need to find the fluid flow for the fluent. Okay, when we click this fluid flow fluent, we can see there is up to 6 steps to this simulation. Okay, the second step, we need to do the geometry. We need to design the pipe. Okay, this is how, this is the example how to do the design. In this explanation, I will show one example only, which is for the T-junction. So we just need to enter our data, which is the diameter for our pipe T-junction and the length for this these three pipe. Okay, after we finish draw or model our design, then we can move to the mesh. Okay. When we enter the mesh, we can see we see and select the water inlet and water outlet.
Water outlet.
Yeah.
Oh,
Yeah, clever, very clever.
so clever. Clever boy.
So diameter
Kenapa?
we use 17 millimeter.
Inlet berapa?
Inlet,
Meter inlet.
Diameter.
we use same diameter for these three.
Outlet and in.
Sama
Yeah.
sama diameter.
For the water inlet, only have one hole at the bottom, and outlet have two.
Two side.
Two side, left and right. So after we set all the water inlet, meshing, and face sizing, body sizing, we can move to the setup. Okay, this setup, we need to insert all the parameter to run the calculation and simulation. Okay, for this flare launcher, we need to choose double precision.
Oh yo. So heavy.
Berat nanam.
Let's
This one
Okay.
set up for the water flow. Yes, sir.
What?
This one set up for the water flow, yes, sir.
This one we need to set up all the parameter.
Parameter
For
first.
example, the velocity, the material we use. For the water flow, we already set up at the mesh already.
So the velocity masukkan sekarang.
Yep. All the value we need to enter right now. As we can see, we already have the water inlet and water outlet. You see the
This
arrow
one for
thing.
the material lah.
Oh, that
Yeah.
one, the flow of water ah.
Yep.
So after we enter the
This one for
velocity,
the
then
material.
the simulation can run.
We need to enter the material, the velocity, all the necessary thing.
Where sir? Where
Okay,
we
for
need to
example, the viscosity. The Vsauce.
Vsauce.
We choose model for K epsilon, two equation.
What's
Ah,
I get it.
yeah, okay. This is
I see.
the parameter, and then the material we use. For
Fluid.
example,
Water.
for fluid, we
Air.
use air and water liquid.
Air.
Yeah, the water liquid you use H2O.
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 Yeah.
Normal water lah.
Normal water in normal temperature. Okay, and then method ni kena Sekejap. Dah keluar. Pisang. Okay, for the method, we choose the scheme simple. Because I don't like complicated thing. So we keep it simple, okay?
Okay.
I get it. Simple.
For the spatial discretization, the gradient we use least square cell base, pressure, second order, momentum, so second order up one, turbulence kinetic energy, first order up one, turbulent dissipation rate.
I think upwind sir.
Upwind. Upwind.
Yeah, upwind.
Yeah. My bad.
My bad. Thank you, Aimin.
Okay. Thank you, Aimi. Okay, for next, we can click the monitor and find the residuals for the graph. So if you need to, if you want the precision data, you need to change the value up to -6 decimal places. And then initialization.
Oh, so many things we need to do before
so
we
many
run the
things.
simulation.
Yeah.
Of course.
Okay, for initialization, we choose standard initialization. And
What?
then
Standard.
Why standard?
Because we keep low-key.
Because you don't like complicated.
Yeah, like I said before.
Yeah.
Okay, and then relative to cell zone, and we put the initial value for the pressure, x velocity, y velocity, z velocity. Okay, why only y velocity have value?
Because y is inlet.
Why?
Velocity.
Just do it.
Initial velocity.
Only
Am I
y have value. X and z don't have value.
Okay.
Because when water flow, it only drop to the x axis, y axis.
Where is this?
Yeah.
Oh. I
Okay.
see.
And then turbulent kinetic energy and turbulent dissipation rate. Then we click initialize. Wait for a while, then we can
Right.
go
Run the calculation.
for run the calculation.
Oh, this one calculation, not simulation lah.
Both.
Oh, it's same thing lah.
Yeah, it's the same thing. It calculate first and then it do the simulation.
Oh.
Okay. Allah. Yang berapa tadi? And then we set the parameter for the number of iteration. We put 200. And then we click calculate the data. So
Yes.
yes, yes.
I think yes. I think so.
So we can see the
Uyu.
The graph.
program do the calculation for our simulation.
Ah.
Usually, how long it takes to complete the calculation?
If we put 200 iteration, only take a while. But if you put up to 1000, oh, very very long.
Very, very long.
$200. Wow.
Calculation complete. So after the calculation complete, we can go to the
Next step.
next step,
Which is
define report, and then surface integral. We can get the data from this. Okay, you click the phase average. Okay, for example, you want the pressure value for this simulation, and you choose the water inlet and water outlet, and then compute. After you compute, it will show the pressure at the console. Static pressure, water outlet,
Water inlet.
Water inlet.
water outlet, water inlet.
Water inlet.
Yeah.
so
Okay, for density, you can know.
Oh,
So
we
basically
need
the
to do
density,
one by one
basically
lah.
the same. Yeah, one by one.
Velocity.
You is the velocity and turbulent mesh. Okay, after we done,
Okay.
we save this simulation and then update at the solution. After we update, we can edit and we can see how our water flow in this file. Wait, then we can see the result. We need to update first. Don't forget.
Okay.
Okay, this is our T junction pipe. So if we want to see the water flow, we click this streamline and select the starting point water inlet, and then enter the number of point, for example 50, and then the indicator velocity, and then apply. Yeah, see, we can really see the water flow.
Oh, so red is refer to?
Red refer to the highest velocity and blue refer to the lowest velocity.
Okay.
We can see this from the inlet, the velocity of water is fast, and then when the water split into two, the velocity drop.
I see, I see.
Because it split to two dua ruang, so dia menurun lah kan?
Okay, that's all for the simulation. Thank you.
Thank you, Khairil.
Thank you.
Don't forget the attendance, yeah.
So for the next step, we
Noted, sir.
can start our video presentation.
Yeah,
Can start record.
yeah.